Okay, yesterday we finished off the chapter 24 stuff. Chapter 24 was the discussion about the loanable funds market. We said chapter 25 we're going to start next week, and chapter 26 is for later in the course. So we just skipped to chapter 27 so that Yanni could come next week and do chapter 25 with you, which I don't think is a problem because I think chapter 27 fits nicely. We're coming out of that loanable funds market and out of chapter 23. It's nice to talk about chapter 27 before worrying about chapter 25 where we talk about money. So I quite like it this way. We'll finish off the chapter today, which means we will have time next week to do revision and still be sort of a little bit ahead. We're sort of one lecture ahead kind of idea, which is nice. It's always better to be ahead than behind. So chapter 27, we can just briefly recap what we did yesterday. We're introducing the Keynesian model. Okay, we've seen that, well, first of all, it's a short run model. In the short run, what do we mean by the short run? We mean that prices are fixed. Okay, in macro, short run, prices are fixed. In the long run, prices vary, and then we can think about something called like the very long run, where capital, labor, and prices vary. So in chapter 27, we're getting introduced to the idea or distinction between planned expenditure and actual expenditure. So we're used to seeing our equation now, our measurement of output, y, is equal to c plus I plus g plus x minus m. So y represents our actual expenditure, which may be different from our planned expenditure. Why are we interested in this Keynesian model anyway? I mean, we've measured GDP, we know how to measure it. Well, what Keynes was interested in was in explaining why output goes up and down over time. And he said one of the reasons that it might be the case is if prices are sticky. Okay? So in the short run, prices don't adjust properly, which is why we're starting to look at this model where the prices are fixed so they don't adjust at all. We want to see how it is that we might end up with this up and down variable business cycle pattern, and we're going to be using our expenditure approach to measuring GDP to understand this pattern that we see. Okay? So the distinction between aggregate planned expenditure, which we call AE, which is really our aggregate planned expenditure, the difference between this equation and the equation that we're used to seeing where output is equal to c plus I plus g plus x minus m, is that I in this equation may or may not be different to I in this equation. Okay? So I in this equation is what we would just call actual investment, whereas I in this equation is our planned investment. Okay? If our actual investment equals our planned investment, then we will have a situation where output equals aggregate planned expenditure. We've also extended our expenditure approach equation by taking C and giving it its own function, and we're making consumption a function, first of all, of something independent of our income, and then something that is dependent of our income. In the terminology, or in terminology that you will hear more about, I'm sure, what we say here is that C is an endogenous variable. An endogenous variable means that it changes when Y changes. C changes when Y changes. That means it's an endogenous variable. We'll see that I is not going to change when Y changes. G is not going to change when Y changes. X is not going to change when Y changes. So all three of these variables are therefore called exogenous variables. Okay? Exogenous variables have got nothing to do with Y. They've got nothing to do with Y. When these variables lead to a change in Y, but a change in Y does not lead to a change in these variables. So these variables are exogenous variables. As for M, imports, what we'll see is there's two ways we can look at M. We could consider M either to be an exogenous variable, or we can consider it to be an endogenous variable. Just depends how we want to how we want to say it's determined. So we'll look at both cases where in one case it's an endogenous variable, in another case it's an exogenous variable. Otherwise, C is the only endogenous variable if we treat M as exogenous, and it's endogenous because it varies with Y. If M varies with Y, then it would also be endogenous. So what we're going to look at then is our consumption function and our savings function. Our consumption function is upward sloping. Consumption function is just the graphical representation of this equation, C equals A plus YB. C equals A plus YB, that's just a linear function. It looks a lot like what you would have seen in high school mathematics. Y equals mx plus c, that is a straight line function. C is your intercept, and A is your intercept in your consumption function. M is your slope, and B is your slope in your consumption function. S, yeah.
Sorry, when you call, sorry, did you say I, G, and X?
Yeah.
Endogenous variables?
No, I, G, and X are exogenous variables.
Does that mean they have no effect on aggregates?
No, it means that if I change I or G or X, it will affect Y. Okay? But if I change Y, that doesn't feed back and affect I and G and X. Right? However, if I change C, like let's say A increases, right? If A increases, C increases. If C increases, Y increases. But if Y increases, C increases, right? So C is an endogenous variable. A change in Y also affects C. Endogenous. Okay? M, as I say, we will consider two different cases. One where it's endogenous, which means that a change in Y will affect M, and a change in M will affect Y. Okay? And another case where it's exogenous, where a change in M affects Y, but the change in Y does not affect M. Okay? So our savings function then, in relation to our consumption function, is basically like a kind of an inverse of the consumption function. So the intercept for our savings function is just the negative of the intercept of the consumption function. The slope of the consumption function is B. The slope of the savings function is 1 minus B. Okay? Sorry. Yeah, just on that diagram, any questions on that diagram at this point that you want to raise? No? Okay. Then the slope of our consumption function, which is given by B. B is less than 1, so our consumption function will be flatter than a 45-degree line. A 45-degree line has a slope of 1. Given that our consumption function has some positive intercept and it has a slope less than 1, that means at some point it must cross the 45-degree line. At the point where the consumption function crosses the 45-degree line, we know that consumption, which is measured on our y-axis, is equal to disposable income measured on our x-axis, right? So if consumption equals disposable income, then we know that savings must be 0. We're not saving any of our disposable income, we're consuming it all. The slope B is given by the change in C divided by the change in disposable income, okay? In other words, a standard slope formula, and we call B whoa. Okay, that's interesting. We call B the marginal propensity to consume. I'm not sure why it's got a wiggle. Weird. Okay. Anyway, today we're writing with a wiggle apparently. So B is the marginal propensity to consume. Okay? The slope of our savings function, which is 1 minus B, is our marginal propensity to save. Any questions about these diagrams at this point? No? Okay. So the slopes and the marginal propensities. The slope of the consumption function is the marginal propensity to consume. The slope of the savings function, the marginal propensity to save. Obviously, consumption expenditure changes when disposable income changes, and disposable income changes when real GDP changes. So what we will continue to, the discussion today will continue drawing the link between disposable income and real GDP. How are these two linked? But any increase in disposable income is going to cause a movement along the consumption function. So an increase in disposable income leads to an increase in consumption, and vice versa. We then have a statement here about the import function. I will read it, and then we will talk a little bit more about what that means. So, obviously, imports are one of our components of GDP. The relationship between imports and real GDP is determined by the marginal propensity to import, which is the fraction of an increase in real GDP that is spent on imports. In other words, what is being described here is an endogenous imports. I have no idea why this thing is doing this. Okay, endogenous M. It's calculated as the change in imports divided by the change in real GDP. In other words, the marginal, if we call imports, okay, if we let imports equal capital M, then what we're going to do is we're going to call capital M equal to a function. We're going to call little m the marginal propensity to import, and it's going to be a function of output y. It might even be easier just to try and write with my mouse here. Okay, so this little m is going to be called the marginal propensity to import. Okay? That's what it's describing here, and we'll talk more about what that means. We now want to look at the relationship between that consumption function that we looked at earlier and real GDP. We know that real GDP, y, is equal to, oh, it's actually really annoying, y is equal to c plus I plus g plus x minus m. Okay? What we're now going to do is we're going to plot we're going to plot y against aggregate expenditure. And we know that aggregate expenditure has a very similar function, except that the I is slightly different. It's planned. Okay? So we're going to treat I as exogenous, we're going to treat G as exogenous, and we're going to treat X as exogenous. And in terms of our consumption function, which is made up of two components, A plus BY, A is also exogenous. Okay? If A is exogenous, what this means, A being exogenous and any other variable being exogenous, what this means is that as we change the level of y, the level of these exogenous variables stays constant. So if we want to try and understand the relationship between real GDP and aggregate planned expenditure, if I just plotted I against aggregate planned expenditure, are you happy that the relationship must be a horizontal curve? There's no relationship between aggregate expenditure and real GDP. It's exogenous. Is everyone happy with that? Yeah? Happy? So yeah, like if people mumble stuff, it's really difficult. Just like say with some kind of conviction or put your hand up like that. Yes. Okay, what are we confused about at the moment? Okay, so what we're going to say is investment is just, let's give it a number, say 100. Okay? And it doesn't matter what the level of GDP is. Okay? Firms are planning to spend 100 Rand on investment. Okay? So in other words, I make a decision today, I'm going to invest 100 Rand. It doesn't matter what the economy does next year, I plan to invest 100 Rand. You happy with that? So it doesn't matter what the level of output is, that's my plan. 100 Rand. Okay? That's my planned investment. Everyone happy with that? Okay, cool. Government, same story. It's exogenous. Government says, doesn't matter what the economy is doing next year, we're going to spend 100 Rand. Okay? If I now add the government spending plus 100 Rand, right, I would now be at a level of 200 Rand. And you're happy that this level, 200 Rand, so in other words, here's my intercept on this side of 100, here's my intercept on this side of 200. It's independent of real GDP. I can change Y, it makes no difference to I, and it makes no difference to G. Everyone happy with that idea? That's what a horizontal function is telling me. Yeah? Okay? Same story with X. We're going to export. Who buys our exports? Foreign people, right? Foreign countries buy our exports. Does it make any difference to them what our economy is doing to the amount that they're going to buy from us? Okay? So it's exogenous. And let's say that they're also going to buy 100 Rand's worth of goods. So now it's 300 Rand. I plus G plus X, 300 Rand. Each level, we're just going up by 100. And now we've got this orange function, which is I plus G plus X, and it is independent of real GDP. Yeah? Okay. If I add consumption to this I plus G plus X, is my consumption function also going to be independent of real GDP? No. We know that my consumption function is dependent on output, real GDP. As output increases, consumption increases. So if I now take aggregate expenditure I plus G plus X plus C, are you happy that this function is now going to be an upward sloping function? Okay? Now what you see here is we've got a change in the slope once we add imports. Okay? Why do we have a change in the slope? That's because of a marginal propensity to import. I'll show you exactly why that slope changes just now. But if we include a marginal propensity to import, in other words, here we've got aggregate expenditure now being C plus I plus G plus X minus M. Here's our function. It's upward sloping. Okay? M depends on output, right? And it's negative, which is why our slope, this function swivels inwards, why the slope gets shallower. Okay? Again, I will talk more about why that slope changes in that way in a moment. For now, are you happy that aggregate expenditure C plus I plus G plus X minus M, if I'm going to plot aggregate expenditure against real GDP, I'm going to have an upward sloping function? Everyone happy with that idea? Cool. So the relationship between aggregate planned expenditure and real GDP can be described by the aggregate expenditure curve. That's this pink line here. That curve or that schedule lists aggregate planned expenditure generated at every level of GDP, and the curve is the graph that we're talking about. So the schedule we'll see just now as a table. It's basically the combination of every single one of these points. Induced expenditure is expenditure that depends on the level of output. So the two different types of induced expenditure that we have are consumption expenditure and import expenditure. Both of those are induced expenditure. What we mean by induced expenditure is that there are endogenous variables. They change as Y changes. Right, so the sum of investment, government spending, exports, those are the things that do not vary with GDP. They are exogenous variables, and we also refer to those variables as autonomous. Okay? Exogenous variables are autonomous. Those are two different terms for the same thing. Induced variables are endogenous. Again, two different terms for the same thing. Any questions at this point? Cool. Yeah.
Sorry, so aggregate expenditure and real GDP are not the same thing.
They might be the same thing, but they are not the same thing all the time, right? In other words, if I put in a 45-degree line here, at some point my aggregate expenditure curve is going to intersect with that 45-degree line. Where that intersection occurs, are you happy that the level of GDP will in fact be equal to the level of aggregate planned expenditure, right? So there is one point where they will be equal. But the curve, the aggregate expenditure curve, at every point along that curve, aggregate expenditure is not equal to GDP. It's not equal to GDP at every point along that curve. There's only one point where it crosses that 45-degree line. Okay, so this was the schedule that your textbook shows you, but it's not in the slides for some reason, so I just photocopied it. If we're plotting real GDP against all our different variables, and then ultimately against aggregate planned expenditure, at point A, our consumption expenditure, so we've assumed in this example here, given that point A takes is the intercept of this pink line, which happens to also intersect with this orange line. What we're assuming on this pink line is that this little variable here, A, is 0, because there's no autonomous expenditure or a consumption expenditure, because our consumption function just starts at exactly the same point as our I plus G plus X function. So if A is 0 is what we've assumed. So consumption, when real GDP equals 0, consumption is 0, but investment is 2, government expenditure 2.5, exports 2, and our imports, we have a marginal propensity to import, which means as the value of Y changes, so our imports change. If our value of Y is 0, our imports are 0. So our aggregate planned expenditure is 6.5. That is our intercept point. As our real GDP increases, so our real GDP goes to 5. What happens to consumption? It increases to 3.5. That's induced consumption. Our investment remains unchanged, our government spending remains unchanged, and our exports remain unchanged. But our imports have now changed. Why? Because imports are also an induced variable in this example. What is our aggregate planned expenditure? C plus I plus G plus X minus M. Our aggregate planned expenditure is therefore 9. GDP is 5. Aggregate planned expenditure is 9. That's point B. Aggregate planned expenditure 9. GDP 5. Are you happy that at that point, aggregate expenditure is not equal to GDP? Right? That's what our schedule is showing us. Okay, continue with the same process. As GDP increases, consumption increases. As GDP increases, imports increase. Our aggregate expenditure is just the sum total of each one of these columns. As real GDP increases, aggregate planned expenditure is increasing. Okay? Are you happy that at point E, real GDP is equal to aggregate planned expenditure? Okay? So what that means is if I were to draw a 45-degree line here, and it won't be straight because for some reason this thing is jumping all over the place. Oh, that's a bad way to do it. So if I draw the 45-degree line, which is really difficult, it's going to go through point E. Okay? So that is the point where aggregate expenditure equals real GDP. That's what our schedule is showing us. So actual expenditure versus planned expenditure. As I said in yesterday's lecture, this entire model hinges on this idea of planned expenditure and the difference between planned expenditure and actual expenditure. Actual aggregate expenditure is always equal to real GDP, but not always equal to aggregate planned expenditure. Okay? Therefore, aggregate planned expenditure is not always equal to real GDP. Why? Because what ends up happening is firms have unplanned changes in inventory. We're going to explain what that means in a moment. So this is unplanned. These inventory changes. What I'm going to do, just going to save this and see if I write over here whether it has the same jumpiness. Okay. So where is our equilibrium level of expenditure going to be? It's going to be at the point where the aggregate expenditure curve cuts the 45-degree line. And at this point, I realize I was meant to. Sorry? Exactly. Yeah. So let's, at this point, so we've spoken about aggregate expenditure curve. Let's just go back one step, just finish off this discussion that we had yesterday with the consumption function. So the example that I gave to you was if we have an autonomous level of consumption 10 with a marginal propensity to consume of 0.5 and letting taxes equal 0, so the consumption is just a function of output, and we don't have to worry about the distinction between output and disposable income. And then plot the consumption function, then plot the savings function, then change the value of autonomous consumption to 15 and show the change in A on your graphs. So what you should get, what you should have plotted, so the consumption function, if we're plotting output against consumption, and if we have, in fact, is to underneath this a savings function. So we've got output versus savings. Let's add a negative. Then our consumption function should have an intercept value here of 10. From this point, it then increases. If we include our 45-degree line, so this is 45 degrees. I see it is actually a little bit jumpy in this program. It's just smoothed nicely, which is, I don't know, obviously something to do with the tablet. So consumption, this intercept should be at a point where y equals 20. Okay? On your savings function then, where y equals 20, that is where our savings function should cross the value of 0. So in other words, our y-axis at the value of 0. Our intercept should be negative 10. This is our savings function. Okay? Everyone happy with those graphs? Any issues? If our level of aggregate expenditure, if our level of autonomous consumption increases to 15, we draw another consumption function which is parallel. Doesn't look parallel, but it's supposed to be parallel. We've got another intercept value. What was the intercept value here? 30? You happy with that? Cool. What would happen to our savings function? Our savings function would have shifted down, and our intercept happens at the same value, 30. So let's call that S1, S0, and C0, C1. Now, the interesting thing here was that the change in A was equal to 5. You happy with that? Change in A was 5, but the change in output was not 5. The change in output was 10. Okay? The reason that the output changed by greater magnitude than the change in autonomous consumption is because of something called the multiplier effect. And we're going to introduce the multiplier effect in a moment. Everyone happy with this at this point in time? Would you like to take a break?